Good evening all. Am I audible? Yeah, Ajay, good evening. Shyam Sundar Rao, good evening. Ivantika, good evening. Mamta, good evening. Redivari Bhaskar, yeah, good evening. Good evening, Prakash. Maunika, good evening. Shivakama Sundari, good evening. I hope I am audible. Okay, so this is Indra from Pantech E Learning, and today we are in our 11th day of this 21 days masterclass on Jetson AI, right? So for some network issue, yesterday we can't able to continue the class, right? So today we are going to talk about the yesterday's topic, which is we are going to build and train neural network, right? I will try to combine yesterday's session and today's session, but let's see if we have time for that or not. Okay, I hope you're all ready. So let me start where I left yesterday's session, right? Okay, so here I'm going to create one more new Python file. So let me create it here. Let me name it like TensorFlow demo using artificial neural networks. Okay, so here let's start from the scratch. So first I need to import TensorFlow as TF. So instead of every time I'm using TensorFlow, I just use TF alone. So let me hit enter. Okay, so now once it is imported, we need to check, right? So TF dot config visible devices. Okay, we need to check whether our GPU, what happened here, TensorFlow, sorry, we need to give one more thing, I forget that, config dot get and then visible devices. Okay, so now CPU and GPU is available. At the same time, we can also check for GPU alone. So TF dot test dot is GPU available or not. It should give us true. Yeah, we got it. Okay, so now GPU is available. So now we can go for including data set, and for operating the data set we need a library called pandas. So again I'm going for import pandas as PD. Okay, so we didn't get any error over here. So now let's read a CSV file in it. I have already loaded my iris.csv file over here. Okay, so we got the file. Yesterday itself I told you that how to get that file, but once again I want to remind you that there is a thing called google.com. You can go over there, and in the data set there is a lot of data are available here. You can take whatever data that you want. I just got iris.csv file from here. Okay, so it is nothing but just a flower, right? So you can go over here and get your data set whatever you want. Okay, you have to load it over here. Once you got downloaded in your Jetson Nano, you can just go for like upload, and you have to select the file and just open it. It will come to your file over here. Then you can directly open that folder in the program itself. Okay, so now we are going to read it. Okay, so for that I'm going to create one variable called data. Here I'm going to read it using PD library. So PD dot read underscore, that is a CSV file, right? So inside we need to pass that file name minus iris.csv. If I hit enter, okay, so now let's see what are the data present inside that particular file. So data dot head, if I just pass this and hit enter, it will throw all the contents that are present inside. So actually we are moving towards to creating a particular workflow, this TensorFlow, and that is what we are trying to do. So for that you need your target features separate and ready, then only we can proceed. Okay, so for doing that particular task here, we are going to split the species separately. Okay, so first let's pick the columns alone. So using data dot column, if I hit enter, again what happened, data frame has no attribute called. Okay, fine. Okay, data frame object has no attribute called column. Okay, so let it be. Let's do one more thing. So here, see this data, let me pass this and see what happened. Okay, so inside I want to give it like sepal length centimeter. Okay, and then sepal width centimeter, and then petal length centimeter. Sorry, I forgot to add the colon over here. And then petal width centimeter. Okay, and let me hit enter. Here I'm going to assign y data of that particular species over here. Okay, let me hit enter and see what will happen. Okay, so now let us our x and y alone. Let me hit enter. Here we have separated the things. In x we are only having sepal length, sepal width, petal length and petal width, right? So the machine learning or deep learning models or mathematical entities that could work only with numbers. As you could see here, species are only in text, right? So over here we are having species only in text, not in numbers, and the remaining are in numerical values, right? So now let's go and check for our y over here. Okay, so let me print y alone. So here we are having species alone. So we have separated species and the numerical value separately. X will contain all the numerical value like the sepal width, sepal length, petal length and petal width, and y alone having all the species name, which is Iris setosa. Okay, so now see this, when we go with species, actually there is some kind of issue, especially when you go for a machine learning kind of problem solving method. You would be turning them into numerical representation like 0, 1, 2 and so on. For example, I have two classes, okay, like male and female. So I will go for like 0 and 1 in such way. So like 0 for male and 1 for women, something like that. Okay, and then now here you could go for unique values. So you could go and select the species as well. So how to do that? Here I am going to give like see y of species dot unique. I go for this particular command. If I hit enter, see in the array we are having three different things: Iris setosa, Iris versicolor and Iris virginica. The data type is object. Here there are three unique values you have. These three are three different unique values which are available now. So the problem is you can convert this into 0, 1 and 2 in a machine learning kind of scenario. If you go for deep learning neural network, if your problem is a classification and especially in that it is a binary classification, no issues. You can turn as 1 as 0 and another one as 1. So you can have it like y which is equal to a single column. But if you want multi-class classification. For example, it's goes beyond 2, 3 or 4, something like that in the sense. Then instead of turning them into 0, 1, 2 or 3, something like that, you have to actually encode it in binary, which means, for example, see this pd dot get dummies of, I just going to pass this y. Okay, so here see, we are only having species iris setosa as 1 and the remaining are 0. Here I have 3 classes, like so I got 3 different column names, and for each column either you get 1 or 0. So here 1 represent for index 0, it is iris setosa. If it is setosa, you will get 1 here, and the remaining will be 0, that is encoding in binary. So if you have like 4 multi-class, if you go for neural network, in both the cases, you have to go and turn it, and you will be turning it into 4 columns and so on. So you could use dummies over here. Okay, so now this is going to be the y for me now. Okay, so for that I am going to save this in y variable. So pd dot get of dummies. Let me hit enter over here. So now let us again, sorry, what happened? Let me pass x again. We are having the same thing. If we check for y in the sense, it should, now our y has changed. So previously we got only iris setosa alone, right? So now I changed my y to this. We are having species, 3 different columns over here. So now let's go for another thing, which is x dot shape. We are having 150 columns and 4 rows. Sorry, 3 rows from, 4 row means 0, 1, 2, 3. Actually 4 rows, the number will be 3. 0, 1, 2 and 3. Actually we are having 4 columns over here, right? So from 0 to 150, 149. So it will be totally 150 rows, and we are having 4 columns, right? So 150 rows and 3 columns. So here it will be like 150 rows and 4 columns. Okay. Okay, so here I am just going to use a simple method. For example, let me just take a method called sample, x of sample. I just going to pass some random number, 150, that we are having 150 rows. I am going for 120. So let's see what happened. Randomly it will pick some 120 records. So this will take randomly 120 records of my sample. So randomly pick 120 records of the samples which are available with me. Okay, so here I am going to, what I am going to do is that here I am just going to choose this as a X train. X train is nothing but training model. Okay, so we are going to use this data to train. So I am going to assign this X sample of 120 records in a X train variable. We are going to use this particular data as for training. So the relevant testing data should also be picked. So if you go for the train first, so let me hit enter, and here I could just go and get that X train index of it. For that, X train dot index. Okay, so here it providing some index value over here. So the length is 120. Okay. Okay, so because I need the respective answer for each, here we got all the index value. So now let's do one more thing, y dot loc, location. Okay, so here I am going to put this inside this bracket. Okay, so let me hit enter, and we are having something like this. Now this is changed to species iris virginica. So whatever the order you have, okay, so you have the same thing in here as well. So 120 rows and 3 columns available now. You pick your x and y value for training data, right? So we are having now like y dot location of this x train of index value, right? Okay, so now I am going to put this in another variable called y train. So we are already having the x train datas, and now I'm going to putting this inside the Y train data. So now we got our X train and Y train. Every time it will pick new samples. Okay, so that's for now. Now let us move to the next part. Okay, now it's time for us to go into ultimate step. We have prepared all these things and we need to create our neural network now. Okay, so we have done with the data that we want for the neural network, training the neural network. Okay, so before that, let me share you one thing about the internship. So you can convert this 21 days masterclass into 30 days internship on Jetson AI. So in this 30 days of internship, you will get 30 days of recording sessions, 30 days of presentations, 4+ exclusive project source code, and you can join to our VIP community group and you will get LMS access for 90 days. And after registration, you will get your internship confirmation letter, and weekly there will be a live session. You can clear your doubts and queries with your mentor, and there will be a mock test, assignments and tasks as well. And after completing the 21 days of masterclass, you will get your participation certificate and then you will get your internship certificate also. And this is only for 999 plus GST, and here I provided the registration link, and we have also provided the registration link in the chat box itself. So batch 3 has started few days before, so this will be closed in the upcoming Saturday. So while making your payment, don't forget to add your name, mail ID, phone number, which department you are from, which institute or organization you are from, and don't forget to mention the domain. You have to select Jetson AI, right? Okay, so you will be doing 4+ projects with me in this particular internship, and batch 3 is going to end on coming Saturday, and use this chance wisely, right? Okay. Okay, so now let's move to our topic again. Okay, so first, neural network with TensorFlow, right? And let's implement it now. For that, let me import from TensorFlow Keras layers. I want to import dense. There is no error, which means they have successfully done it, right? So here what is called dense? This particular dense is really important. Why? Because this dense is what you are going to use to create a layer of network. So if you are having dense, it actually tells you that you are having layer. In that you can decide how many number of neurons you want. That's up to you. You can go for 2 layer, you can go for 3 layer or something like that. Shyam Sundar, I have noted it down. I will convey this to your coordinator and she will add you as soon as possible, right? Okay. Okay. So now, here we need to create variable or an object known as model. Okay, so let me create that model. Okay, so which is going to be combining all these things. So let me go and pick TensorFlow, Keras, and we have something known as sequential. So TensorFlow for TF and Keras dot sequential. Okay, so let me hit enter. So if you pass this, you will getting a particular architecture where you could add layers to it. Okay, understand that we would be building a layer by layer and step by step in TensorFlow. So this is something like you going to build a neural network. So you created a architecture. Totally now you have some empty pieces where you going to fill your neurons and neural network layer now. Okay, so if I want to add a first layer, and then we could use like model dot add. Inside we need to pass the main thing, which is dense. Okay, and then inside I'm going to pass few things. One is 10, and then activation. We have already learned about this, right? So here I'm going to take ReLU activation function, and then input shape. Okay, which is equal to, here I'm going to pass 4 comma and I'm going to leave it. So what is this particular line? What this particular line is about? So inside I have passed a dense, and inside of dense I could choose how many neurons I want. Here I added only 10. So 10 neurons, and the activation function here is ReLU, and finally the input shape. So if you are having initial layer or first layer, whenever you are having first layer, you will be having this input shape. So that shape will define how many columns you have. I have already have 4 columns, right? So that's why I have passed 4. So 4, that is the syntax. This is how you can pass your column. So this is the function. You have 10 neurons in it, and the activation function, which is nothing but ReLU. Okay. So now let's just get the summary, and note here I am not adding any other layer. Okay. I am just going for the summary. So model and then summary. So here see, model is sequential, layer, type, output shape, parameter, then something like the total parameter, that is something. So I have just only one layer and then one input layer. It will be getting 4 column, and I would be giving you the output of 10 neurons. So that is the idea. For example, we have a model. We have a model now, and which has only one layer out of it. So let me just go for just a model. TensorFlow, Python, Keras, engine, sequential at some random value. Okay. So now I am having only one model, right? So sorry, let me delete this. We don't need it anymore. Okay. So okay, so initially it was a sequential. Every time you or refresh it, or every time you or add it in the same one, so that you are not stacking on top of it. So you creating and stacking whatever you prefer. Okay. So next I am going to add another layer, which is going to be our second layer. Okay. So where I am going to add is here. Okay. Here I am going to add. What I am going to add? Model. We have already done this over here. I am going to add this here, and one more line. So let me just delete this particular cell. Okay. So here I am going to add the second layer. So model dot add inside dense, here 32 activation, which is equal to ReLU. Here we don't need input shape, because for every, the initial layer or the first layer, in the sense we need to pass that input shape. How many columns do we have? In the second layer, third layer, we don't need to pass it anymore. We just need how output I want. How output neurons I want. What is the activation function that I am using? That's what we need. So here, instead of going for 10, I am going for 16, because multiples of 8 is always preferable over here. So first is 16 and then 1, that is the 32. Okay. So let me go for it, and let us delete this. We don't need it anymore, because, or let it be. Okay. Okay. So here I would like to change 16, because I don't want to it be a 10, 16 and 32. So multiple of 8 usually we prefer, and the activation function is really over here. So remember, whatever number you pass, when you increase, you are going to pick more feature. So if you go for 16, it will give output in 16 neurons. Or for 32, it will give output in 32 neurons. And also there is a problem when you increase this particular number, because it is going to increase the complexity, which means the amount of GPU consumption and hardware requirement will be high, and it will be take and all. So that will be a problem over here. Okay. Okay. So now in this line, I am going to give like model, or we can go for this line also, Okay. So model x of train dot values. This is what I want to pass. So now the model got inside and giving me the output in a particular shape over here. So shape is 120 in 32. So it will give us 32 neuron as a output, and D type, which is float 32, numpy and something there is. Okay. So now I am going to put this in another variable called output. Okay. So now let's see the shape of it. Tensor shape 120 and 32. So it's giving us 32 neurons and 120 rows. Okay. Okay, fine. So now if we go for something like this, in the sense, you can able to see over here something like that. So here you can see the size of it, right? So you are extracting output of 60 neurons or 32 neurons. If I just take this particular thing and hit enter, and again if you hover, hit enter, and again if I hit enter, you can able to see the changes over here, right? So it will only giving you 60 neurons. If you add that particular thing, it will give you 32. And you are having something like this. Okay. So now we don't need it anymore, or let it be. Okay. Okay. Now again here I am going to add one more line. Okay. As we know, it is a final layer. If it is a multi-class classification, I just want to go with model.add dense. Inside I just want to pass 3 activation, which is going to be the another activation, which is nothing but softmax I want to use. Okay. So this line have the classes which I want. Here I want 3 outputs because I want 3 column. From that, using argmax, which is maximum probability, I would be picking, and here as you know, this is a multi-class classification. So the activation is going to be softmax activation. So this is going to be my simple neural network. So what I have done in earlier is just for demo to just show you how actually it works. So here whenever it gets input, it creates 16 or 32, and that gives to the second line, and that picks the 32, and finally from that we will get 3 output. You could also add more layer. Here I just want to stop with 3 layer only. Okay. So let me enter this one again, this one again. So now we are having something like this, right? 3 layer we are having it now. So previously it only you throw 1 layer, right? So because we have added only 1 layer, now we are having 3 layer. So it's throw us 3 more layer. Okay. So when you call summary, you will get this particular summary of what all things you have, how many parameters would be, and so on. Okay. So my next step will be, I'm going to delete it because I don't need it anymore. Okay. So here now we are going to train our model. Okay. So we need to actually go up for optimizing, or we need to compile it. Okay. So for that I am going to use model dot compile. So inside optimizer, which is equal to, here I go for like Adam, I will explain. Okay. And then loss, we have already talked about this loss function, right? So categorical cross entropy. Let me check with the spell, cross entropy. Okay. And then matrix, which is equal to, here I am going to pass like accuracy. Okay. Okay. So here compilation is very important, and it is necessary because here you are going to mention what is going to be your compiler. Here optimizer is Adam optimizer, and loss function that you know as it is going to be a categorical cross entropy, and finally metrics that will be what metrics you want to view when you train. So here I go with accuracy. So once compilation is done means the model is ready for training. So here I am going to use model dot fit. Inside I am going to pass like our X-train data and then Y-train data, and the epochs I am going to pass like 100, and then batch size I want like 16. Okay, so model fit of I have passed 4 things: X-train, Y-train, epochs which is 100, batch size which is 16. So here epoch is something like one forward and one backward propagation of our entire data set. Is just one epoch. So here I train it for 100 epochs. Epoch is nothing but iteration. So in the theory itself you have heard about all these terms, right? Epochs, forward propagation, backward propagation, and then batch size. So here I go with 16, which means every time 16 rows finish for forward and backward, and then next 16 finish forward and backward. So it will keep on doing until it finishes my 120 records. So if I run this model, it will be training, and you could able to view it also. If you want, let me share my Jetson Nano screen over here. This is a hardware we are using especially for training now, right? So just a minute, let me show you. And here let me go for JTop. It will show you something like this. Here I am going to GPU. Okay, so here see, now GPU usage is about like 28% or 45%, something like that. This is in the oscillation part, right? So let me run this and see what will happen. Okay, so now this is in 0%. It is just in oscillation, but this is not in actually work. That's why it's go for 0, 20 or 40, something like that. Okay, so now let it be, and let me take this aside, and let me take this to the full screen. Here you can able to see actually it's go for from 0 to something like that. Is not mostly in use, right? So here, okay, so once if I run this, let us see what will happen. So let me hit enter over here. Now you can able to see it's actually running. It's doing all the step, and until it will go for 100, you can able to see it doesn't go for 0 and it still keep running. So we have done with all the step. Now it get back to 0 and it will be like in the oscillation from 1 to 100. It finished the training process, right? So once it done, it get back to the 0%. So now the training has been completed, as you could see. So we have run it for 100 times. So let it be. We have run it for 100 times. All our 120 data, 16 rows as forward and backward, till 120 has completed in just one step, which means one epoch, that done for 100 times. So it has printed you the epoch. It is printing 1 by 100, which means out of 100 epoch, it is the first epoch. So here what is 8 by 8 actually means? You went the batch size of 16, right? And totally my X train and Y train has 120 rows, right? So see over here. So let me add one more line. See here, when you try to take 16, then 16, then 16 till 120, you have to do it. So when you divide that 120 by 16, you will get something like 7.5. When you round it off, you will be getting 8. So it has to run that many times so that this particularly can cover all your rows forward and backward. That tells that it complete one epoch, then it's want to do the same process again till 100 times. So here sees the loss, it was something like 1 point something, and the accuracy is like 0.3234 and the loss is like 1.0992. And in next time you can able to see accuracy should increase and loss should decrease. You can able to see it here, right? So you can able to see the loss is actually decreasing. The loss is decreasing, and here you can able to see the accuracy is 0.3234 and gradually it is increasing. This is how we should get the output. The loss should be decreasing and the accuracy should be increasing. So the training was completed and we saw the utilization of GPU as well, right? So you could go and use this for making predictions as well. Okay, for example, let me add one more line over here. You could go and use this for making prediction as well. For example, here I am going to use like data.log. I am going to just pick some random value. Okay, so 87, let it be, and if I hit enter, ID name is 88 and the sepal length centimeter is 6.3, sepal width centimeter is 2.3, petal length centimeter is 4.4 and petal width centimeter is 1.3 and the species is iris versicolor. And name 87 that I have passed, data type is object. Here the predicted original value is versicolor actually, and we got all the features with giving you the output. Okay, so if I do the same thing with one more thing, let's just get the value. It's giving the value, right? So 88, 6.3, 2.3, 4.4, 1.3. This is iris versicolor and the data type is object, right? I got this particular row. Now let's pass this as a two-dimensional array. Okay, so here let me add one more line and like model dot predict. So inside I am going to pass something like the same value. Here I just want to pass these four value alone. Okay, so I have passed this and let me hit enter and see what happened. What happened? It threw me an error. Why? Sorry. We have to put this along with one more bracket. See, 0.110 something, 0.94 something, 0.04 and something, and the type is float 32. So we got the result as 3 value because I have asked for 3 neurons, right? So 3 neurons will be giving 3 output. Now how can I predict it, whether it is a versicolor or virginica or something like that. So here as you see, these values are probability of each, which is maximum probability you can see and use. Okay. Now let's try one more thing. So here let me do one more thing. Here I want to just import numpy as np and here np dot argmasks. Here I want to go for like model dot predict and I want to pass this particular thing. You got 1, right? Here maximum will give you the maximum value, I mean the max, or max will give you the maximum value and argmax will give you the index position of the maximum value. So the index position is actually 1. So the iris versicolor index position is 1. So if you want to go infer, just you can go and look at it. So if I just pass y, you can able to see something like this. Why it's printing this value? We have changed this to something else, right? Okay. Now let's do one more thing. Let us go and add after this and see what happened, right? So I'm going to just pass this particular line alone. Let's see what happened. We are getting the same value like this, right? So why it's throwing 1 means we have got all the values from what? I forget the name. Species iris versicolor, right? So that's why it's printing 1 over here. This is actually print some other value. It's printing the old y value because we passed this y to some other things, right? So I gave the program in the wrong line, I think. That's why it's printing something like this. But the output is correct. I have just passed the program in the wrong line. That's why it's printing something like this. Actually, iris versicolor's index number is 1, 0, 1 and 2. We are getting all the details about species iris versicolor over here, right? So where it is, we have got something else over here, right? Okay, so that's why it's printing as 1. So this is how we train a neural network in TensorFlow and make predictions as well. So this is just a sample code of how to train a simple artificial neural network in TensorFlow. That is another thing called PyTorch. So instead of TensorFlow, you can also use this in PyTorch. So give it a try with some other library called PyTorch and let me know whether you got the same thing or not, right? So I hope you like this session. So is this clear or not? Do you want me to continue the today's session also, convolutional neural network? If you are all okay in the sense, let me continue. Otherwise, let's go for tomorrow's class and see in tomorrow's session also. I will compensate in the upcoming sessions also. I just want your opinion about it. Do I want to continue it? Or let's manage in the upcoming sessions or not? They have posted the attendance, like you just post your attendance and get out of the class, right? I just want all your opinions because all of you have to listen. That's why I'm asking. Do you want to continue? It will take almost half an hour or 1 hour. That's why I'm asking. It will take more than half an hour. Let me continue it or let us continue with some other class. Okay, fine. Let me continue in the upcoming class and let us merge the upcoming classes and talk about the remaining topic elaborately, right? So if I continue this, most of you don't listen, I think. Okay, so thank you all. This is how you can train and build your model. So please try it in a PyTorch library also. Here we were only used TensorFlow. So try it with PyTorch also, right? I think most of the people leave the session because they have posted the attendance, right? So let us continue in the upcoming class. Thank you all. Have a very great day. Attendance link have posted in the chat box. Please go and mark your attendance.